YouTube video out now, man. Like, comment, subscribe.
And as I stated, we have 6 of these, one for each port. And what we'll be doing is utilizing each one of these inside the runner. So I will take each one of the manifolds off after I prep everything. I will give an example of how we're going to clock this in position. So I will get some spacer washers, some shim washers, because you want to make sure it's clocked and lined up appropriate with this dot. The exhaust flow that's coming out of each one of the cylinders, each one of the ports, you want this pretty much facing the back part of the cylinder head. That way this is in line with the flow. It has a second port right here, and this is tapered off. As you can see, these are very nice, high quality. What this will do is this will scavenge. This will allow the airflow to go in through the first port, the second port, and where it's tapered, it allow it to scavenge. But I picked out the weld bungs exactly to mate this properly with these Innovate bungs that I have. When I thread this in to each one of the ports, this sits perfectly just a little bit right above the bottom part of the exhaust manifold, and this is in line with the stream of the exhaust airflow. It's not protruding too deep into the cylinder, each one of the ports, so therefore it's not going to cause a major restriction. But either way, this is all for the process of tuning, for individual cylinder tuning. Once each cylinder is tuned up, then we'll take these back out, put plugs back in, and that'll be the normal operating mode. And we can still leave 1 or 2 in, or if my brother wants to leave them all in, that way we have constant evaluation and data logging for monitoring each one of the ports, just in case we have any type of failure. We'll have that documentation. But let's continue with making progress. We are good for this. We're going to move to the next step. I just got a phone call from the machine shop. He's pretty much wrapping up the balancing for our forged crankshaft and our pistons, our custom J pistons with our line-to-line coatings and everything. So this is going to be turning out pretty good. This is the setup that I wanted before with this engine. So things are really looking good this time around, and we shouldn't necessarily have to do an immediate teardown. We will get the opportunity just to see how far our stage 1 will pretty much go. The stage 1 is a lower compression piston, pretty much a 10-0-1, and still good for forced induction, allowing us to use pump gasoline. Our stage 3 is a higher compression piston. That's a whole nother story. That stage 3 will be going outside in that Silver Beast out there, my TT, with a sequential gearbox and all the bells and whistles. But for the moment, this beast right here, this is going to have the DQ 500 transmission, which is going to be a monster. Of course, I would have loved to have that DQ 500 transmission in my car as well, which I could, but I bought a Quaife sequential. My car is originally a manual, and I wanted to stay with the pretty much the theme of the car being a stick shift car. But this beast right here, this is going to be a monster. We don't have to worry about missing gears, nor do I with the sequential shifter either way. But we're going to have 2 monster 3.6 bills coming at you. Let's go to the next level. Okay, about to remove the intake camshaft again, and I'm going to shim under the hydraulic lifters for a little more performance action and more of a solid valve drain. So let's get this done. Making some progress. I removed the intake camshaft, removed all my lifters, installed lifter shims underneath each one of the lifters. Now my exhaust cam is out. I have lifter shims in each one. Have 2 more to go. What I'm doing is using needle nose pliers just to keep them. These are spring loaded. Drop them down into the bore and just release, and it just drops in there like that. You can see the difference where it's got a half cutout, like right in here. It's like partially missing, and the one that has it, it looks like a complete circle all around. 1 more to go, and then I'll put the lifters back in position. I have a compound, spray-on compound that I would like to test on these gaskets. And I've played with copper gaskets, of course, when my GTI had the block O-ring and different stuff, and used Palomar and all kind of sorts of gasket sealant. But I think the stuff that I've come across is very nice and on point, and will be possibly a slightly game changer, at least for me anyway. and I'm going to experiment with it. So we're going to spray this, give it a chance to set and dry, and this will be prepped for the reassembly of our 3.6 liter and mounting the head back to the block. So let's go ahead, spray this stuff on, give it a chance to dry. And I'm giving it a chance to air dry a little bit outside because the chemicals are toxic. So you must be careful and use extreme caution. I'm over here doing something interesting also. I am prepping to come up with some custom drive shafts also. The one on the left, far side, which is here. This one was the original Audi TT. We upgraded to one like this because this has a larger CV joint. It's a little bit heavier duty. In my opinion, this smaller CV has a tendency of blowing out a lot quicker compared to this heavier duty one. So we do have this size currently on the car with rebuilt bearings and everything all prepped and has been installed, with also an updated carrier bushing bearing also, because these original ones are extremely flimsy. If you see my video and look how flimsy this is, it's just insane. You expect this to support big horsepower? No, because the car wasn't designed with the horsepower figures that we are making in mind. So all this has been upgraded to heavier duty parts. But what I'm going to do is revise this whole setup so that way installation it'll be a lot easier, installation and removal, as well as strength. So I'm going to come up with a configuration that will change this whole setup right here a little bit better, and it'll be something, a prototype that will get used on my TT and as well as my brother's TT. So what I'll do is have the drive shaft shop mock up 2 of them, and we'll test it on the road and make sure that these things can handle easily over 1,000 horsepower. I'll say up to 1,500 plus horsepower. We'll see if it can maintain that. My TT, it's a roadster. Unfortunately, we're going to be pushing close to 1,800 wheel horsepower, which is scary as hell. That's like a super crotch rocket with turbo and nitrous and a rocket on the back of it. But anyway, we're going to come up with something a lot stronger and a lot more reliable. So I'm going to take these end bushings off and start measuring. In the garage, messing with the GTI. It's been a while since I've removed this valve cover. I have a cam combination that produced some great horsepower, and I mean extremely great, but I don't remember the combination. So removing the valve cover so that way I can see what type of cams I'm running, and then I can apply some of this data and knowledge to our 3.6 liter VR6 build. Okay, performing an inspection, and now I have my answer to what I was using. Wow. Okay, I am out and about making some progress. So I'm glad I have some stiffer springs on my TDI because I am loaded up. If you can see in the back, I got 2 VR6 engines. These engines are being prepped for our stage 3 setup, as well as I picked up the parts from the machine shop for Teddy's build. So that is great. So the crankshaft, pistons, rods, everything, the flywheel, or dual clutch, dual mass flywheel, everything has been rebalanced and ready to go. So we do have that. The current machine shop did not have the proper machining for doing a 10.6 degree V-angle bore for our VR6. So we're en route to a different machine shop so that way we can get the big bore for our VR6 engines, the proper bore, and then we're going to take it back to my original machine shop and have them hone it out with our honing plate to make sure everything is nice and true. So let's get this moving. I have cylinder heads all down here. I got a car full of parts, and this car is loaded down. But let's get it going, making some progress. Got more than $1 in the dream, baby. Let's get this done. Yes. Made it to Precision Machine Shop. Hard to see that. Yeah. There we go. And you can see I definitely burnt up a little bit of rubber from these heavy engine blocks in the back. So let's get these in so they can start prepping them for a nice bore. Got some good news. Just picked up the pieces back from the machine shop. So now I'm going to snatch this old crankshaft out. Go in with the new forged crankshaft. Got my rods and everything's been rebalanced. Spec sheet in the bottom with it. And let's get this bad boy put back together and let's go. We are back at it. A revamp of the 3.6 build. And we are ready for some action. I've been doing quite a bit over the past few weeks, coming across some nice products and some nice revisions that will make this engine perform really good to the point where I think I will be quite satisfied for a stage 1 setup. So we have our rotating assembly back from the machine shop. The forged crankshaft, rods, pistons, and everything has been balanced out to spec. All this is ready to go. So we're going to remove the original crankshaft from out of here. The cast breakaway boy crankshaft, because this thing would have snapped with the power we would have been throwing at it. We're going to take this thing out. I'm going to go ahead, clean up the bearings, clean up all the piston squirters, and just do a whole new revamp of making sure the crankshaft with the plastic gauge and everything measures out the spec, and then we'll put this bad boy back together. So let's start getting with the assembly. And now we're back at it again. I'm going to remove the bearings. Make sure I just label everything exactly how I have it, because it really doesn't matter, but I'd rather put each one exactly where each main bearing cap it was at originally. Then I'm going to clean up the bearings, put them in the sonic cleaner to get all the oil off of it, and then we'll go ahead and proceed with the plastic gauge. So we have our bearings removed and all the piston squirters or piston oilers removed as well. So I'm going to clean the piston oilers separately. I have my bearings inside the sonic washer or sonic cleaner. They're being cleaned up at the moment. Let's take a look. That was some heavy duty grease on there, so I have some degreasing solution in here, as well as on a heat cycle. So I'll run that a few times just to get as much grease off as possible. And then we'll go ahead and clean up these journals, reinstall the bearings, and prep to measure for our clearance. Let's get it on. I wasn't expecting to have to do this. This engine assembly grease is so good, it was so thick and laid a nice coating on the bearings that I literally had to put this in a bowl with some detergent and clean and brush off the oil off of each bearing just to get it clean. Lesson learned, what I should have did was wipe them off first and got them as dry as possible. Maybe a teeny bit of carburetor cleaner. Don't want them to get too dried out or brittle. But either way, clean them off first, get as much oil off as possible, and then put them in your sonic cleaner. So lesson learned. Now I'm going to put them in there again, let it go for maybe 1 cycle because they're already pretty clean, and then we'll be good to go. Damn, these piston oilers came out looking good. I mean, they're all shiny. They actually look like these things are new, just from cleaning all the residual oil off it and running it through the ultrasonic cleaner for about 3 minutes. These things look good. Uh-oh, I have an update and a correction. Since testing the other pilot bearings, which had grease on the inside of the pilot bearing for the roller bearings, I initially thought that this would not fit. Now, as I stated in the video before, I bought 2 of these and 1 of these, and I did some major research to track down these bushings, and with the little extra grease on here, this bad boy fits in nice and snug also, and the tolerance is a little bit tighter than this. So this is really off the chain. I mean, this is good. I'm happy with what I've tracked down. This is sweet. Before, it had a little grease on the shaft. This thing wouldn't slide on. So sometimes you have to pre-lube to get it to slide into position. Take that how you want it. But some people used to try to force it on dry. But it proves a little extra lubrication is good. It's good when needed. So we're good. We are definitely good. I have 2 major options, and I'll decide and do even more in-depth detail to figure out which one of these bushings would be even better for use. And these are designed, these are true pilot bushings for extreme use. Nothing that's just generic. These are designed for extreme use. Bingo. Good to go, baby.